This video is about grouped frequency distribution tables. These kinds of tables are used for numerical discrete and numerical continuous data. I'm going to show you how to create a grouped frequency distribution table from a list dataset, and then we're going to have a look at how to do calculations on it as well. So here we have a dataset, and it's the heights of a number of people in centimetres. And we can see that it's quite long, unwieldy dataset, and it might be nice to represent it in a table. Now, if I was to do a regular frequency distribution table, I'd need to have a space for each individual value the whole way from 150 up as far as my highest value of 174. That table would be really very long. It wouldn't be very efficient. So instead, I'm going to group my data points into what we call intervals, and that's going to allow me to create a grouped frequency distribution table. So this is how that's going to look. So I'm going to have my variable on the top row as before and my frequency on the bottom row. And don't forget that I can call frequency f. So I want to decide on sensible intervals then for my heights. And perhaps in this case I'm going to go up in tens, 150 to 160, 160 to 170, and 170 to 180. Each of these ranges is called an interval or a class. And you'll see there that 160 is mentioned in this interval and in this interval. That'll sometimes happen, and that'll be particularly for numerical continuous data. And what it means is that the values in this interval will be all the values right up to 160, but not including 160. The 160 will be included here, and this interval will go all the way from 160 right up to just before 170, but not including 170. So really here, this 160, it's less than 160, less than 170, and less than 180. So if I had 180 on my list, I'd have to start a new interval, 180 to 190. So to complete my table then, I'm going to need to check what the frequencies are for each interval. And at this stage, pause the video and see if you can complete this yourself. So I count 8 pieces of data there in the first interval, and 8 pieces of data in the second interval, and 4 pieces of data in the last interval. If I'm required to build a grouped frequency distribution table myself, it's a good plan at this point to just double check that my frequencies add up to the same number as there are data points in my data set. In this case, my frequencies add up to 20, and there are 20 data points in my data set. So that just means I know that I haven't left anything out. So next we're going to look at calculations on grouped frequency distribution tables with a focus on averages. So first of all, we might be asked for the modal group or modal interval. And modal is just, our modal group is just another way of saying mode. So really what I'm looking for is which group or which interval occurs the most. And I can see in this table there's actually 2 of those. So the interval 150 to 160 occurs 8 times or has 8 data points in it. And the interval 160 to 170 also has 8 data points in it. So I have 2 modal groups in this case. When it comes to the median, I'm generally going to be asked in which interval does the median lie. Well, we know when it comes to median that we need to figure out where the middle piece of data is located first of all. That's our n plus 1 over 2 formula. Don't forget, summation f is the same thing as n. So I know that n is 20 in this case. So when I use this formula, I get 20 plus 1 over 2, which is the 10.5th piece of data. Now I know, of course, when I'm calculating median normally, I look for in this scenario, the 10th and 11th, and I average them. But generally when I'm dealing with a grouped frequency distribution, I don't actually know the individual values, so I can only talk about which interval they occur in. So like in the previous video, I'm going to go to my frequencies and I'm going to just see what happens as I progress through each interval. So I've got the first 8 pieces of data in that first interval. I've got the next 8 pieces of data in this second interval. Now 8 and 8 makes 16. So I'm up to the 16th piece of data, and the next 4 pieces of data are in the last interval. So the 9th to the 16th pieces of data are in this particular interval, so they must both be in the 160 to 170 interval. Note that if I only have access to the table, I don't actually know what those values are exactly, but I can say that they occur in that interval. So the median in this case lies in the interval 160 to 170. Finally, I can be asked to do a calculation for mean based on a grouped frequency distribution table. It's important to note when I'm being asked to calculate mean in this context, I'll only ever be asked to estimate the mean. This does not mean that I'm guessing what the mean is. What it really means is that when I do a calculation for mean from a grouped table like this, that I'm going to have a ballpark figure at the end of my calculation for what the mean is. I know that at the beginning of this video we knew what the full data set was, but frequently when you have a table you don't know the individual values in the data set. And the only way to exactly calculate mean is if you know each individual piece of data. If you only have a grouped frequency table, you don't know every individual piece of data, and so you can't exactly calculate, you can only estimate. And that's why they use the word estimate in the question. So how can we calculate mean if we have a grouped frequency distribution table? Well, the first thing is that we have to add an additional row onto our table. So here I've just made a copy of the same table as before, but with that extra row inserted on top. And I'm going to use that row to calculate what's called the mid-interval value. Now don't forget, the intervals are just these groups here, 150 to 160, 160 to 170, and 170 to 180. The mid-interval value is just the halfway point of each of the intervals. And the reason that we calculate it is that if we only have the table and we don't know the individual data set, and we don't know the individual data set values, the individual data points, then I need to have an estimation for what those data points could be worth. And the best guess that I can make is to say that they're in the middle of the interval. The mid-interval value is easy to calculate. You simply add up the 2 values at either end of the interval and divide by 2. And my first one here is going to be 155. The next one is 165. And the last one is 175. Now, like we said earlier, frequency can be labelled as f. And if you recall from our last video on frequency distribution, I call my variable x. Now, in this case, the x label goes on this mid-interval value row. So don't forget, our question was to estimate the mean. The formula that we use here is the same as the formula for a frequency distribution table. So x bar equals summation fx over summation f. Don't forget, summation f just means add up all your frequencies. We did that earlier in the video. 8 plus 8 plus 4 is 20. Summation fx means take each frequency, multiply it by its variable, and then add all those results up. So how will that look? So in this case, my summation fx will be 8 times 155, 8 times 165, and 4 times 175. And like I said a moment ago, my summation f will be 8 plus 8 plus 4. And now to the calculator to find the answer. So I'll have 3260 over 20. And my mean at the end of this is estimated at 163 centimetres. As an extension, go back to the start of the video and calculate the exact mean of the dataset from the original dataset that you were given. Pause the video here, possibly even rewind and check what the original dataset was, and then go to the end of the video to find out the result. The exact mean is 161.4 centimetres, so quite close to that estimate of 163. Bear in mind, in a lot of the grouped frequency distribution table questions, you won't be given the original dataset, you may only be given the grouped frequency distribution table to work off.